Einstein develops special relativity, 1905, the famous publication. By 1907, though, he's beginning to realize that he would like to generalize special relativity, no longer talking about reference frames which are moving uniformly with respect to one another, but what about reference frames that are moving in an accelerated fashion with respect to one another? What about rotating reference frames? So by 1911, he's got his first, what's called the Prague theory of general relativity, and that will change. By 1913, he's got a version which he thinks is superior. And then the final version of general relativity that Einstein will develop, he's got by the end of 1915, start of 1916. But the famous light deflection that he predicts in 1911 comes out of an earlier version of general relativity. And so he calculates how big should the deflection of light be as light, say, from a distant star just passes by the sun. How much will it be affected? And the calculation he makes turns out to be an answer of less than 1 second of arc. An astronomer at the Berlin Royal Observatory, a man called Erwin Freundlich, is really interested in Einstein's theory. He's one of the very few astronomers who's actually interested in trying to test the results of general relativity. And so Freundlich tries to look at past photographs of eclipses. Can he look at these earlier photographs and see star images and compare the positions of those stars with the sun there at the eclipse, and also when the sun has moved away from the star, because then we should see the deflection. But the images were just not good enough for a range of different reasons. So he decides in 1913 that he would like to engage in an expedition, go to the Crimea in August 1914, take photographs of the sun during the eclipse in order to get the star positions during the eclipse, take photographs at a different time when the sun has moved away, compare the star positions between the two sets of photographs, and then you've got the measurement of the deflection of light. Freundlich leads an expedition, and they go to Russia, and the eclipse will occur at the end of August 1914. But this is not a good time to be a German traveling in Russia, because World War I breaks out, and so Freundlich and his companions and their instruments are taken into custody. They're thought to be spies, and they're held in Odessa for several weeks before, in fact, they're released, but the instruments are confiscated. But what is very interesting about this expedition is if they had, in fact, gone ahead, made the measurements of the deflection of light, they would have come up with an answer which would have been roughly twice the answer that Einstein had calculated based on one of his earlier versions of general relativity. And so the actual shift that Einstein predicted later would be 1.75 seconds of arc. At this point, the prediction that Einstein makes is 0.85 seconds of arc. The first measurements made at an eclipse of the deflection of light that are successful anyway, the result is 1.64 seconds of arc. So what that means is, if Freundlich had gone ahead, made the observations in 1914, the answer would have been about double Einstein's prediction. And then Einstein would have come along later and redone his calculations. Oh, look, my answer is now doubled. I pretty much got the amount that the light is deflected by. Now, would that have aided the acceptance of general relativity? I suspect not, because coming in after the fact, after the measurements have been made, and saying, oh, I goofed by a factor of 2, is not really a very convincing way to verify your theory, I think.